Hello, Professor. In this opportunity, we're going to analyze the suspension system and the tire wear and tire performance. So, for this, the team members are
John Quispe, Ronald Muñoz, Elías Palma,
and me, Cesar Olivas.
My name is Cesar Olivas. Here in the first part we need evaluate the suspension system. For this we have a car Toyota Yaris. We need evaluate the vehicle when the vehicle pass over a bump. So we have the vehicle mass, the spring constant, the damper or shock absorber, the distance, the velocity, and the time. We calculate all this and we can get a response of the vehicle when there are a bump on the road. So we have here the diagram of free body, and we have the constant of the spring, constant of the damper, and the mass. The mass can be a sprung mass or unsprung mass. Here we have the suspension work best if they are excited at frequencies well above their resonant frequencies. So this is important because when the vehicle or the suspension is manufactured, it's necessary evaluate this because the suspension system is one of the most important parts of the vehicle and give comfort and safety to the passengers. Here we have the response or the behavior of the front suspension and rear suspension. It's different the response because every axe give a different behavior. We calculate all this and we have here a graphic to related to the coefficient of damper. Here the answer is 0.30 and we have this here. So this is the response of the vehicle approximately. This is the response for a Toyota Yaris, but maybe if we have a heavy machine or maybe a car of races, we need change this coefficient because this coefficient affect to the response of the vehicle. And here these important parts. The response of the suspension depends on the damping coefficient. And also it's important to keep in mind that the wheelbase affects the vibration of the vehicle and also the suspension. A vehicle with more weight will have a greater vibration.
Well, I explain about of performance parameters. The performance parameters for our suspension system are the mass, spring coefficient, and damping coefficient. And the most important parameters to consider is the spring coefficient and damping coefficient. Since we can configure and regulate the level of suspension of the vehicle and this comfort. When you need change the suspension oscillation, you need change the coefficient spring and damping for the more comfortable and easier driving of the vehicle. This is the most important, the damping coefficient and spring coefficient.
Continuing, here we have tire wear on the Toyota Yaris. When we evaluate the condition of the tires, we found three types wear on the tires. The tires front present unilateral wear. This type tire wear it's on the outside of the tire. In the rear tires, the type of tire wear is central wear. It's produced in, in central of the tire, and the most likely causes are high inflation pressure and vehicle scale. Also, we found the irregular wear. It's produced in the specific location of the tire. The most likely causes are tire block and accidental braking and high-speed braking, and the unilateral wheels produced because incorrect alignment and the steering system is converging.
Continuing that explain, I talk about the tires performance. The first tires performance is inflation pressure, and since inflation pressure increases carcass stiffness, but the reduce contact length. The net influence on cornering stiffness can be generalized across of types of tires. The second tire performance is size and width. For a given load condition, larger or wider tires exhibit a greater cornering stiffness. The three tires performance is tire design, because the lateral components of the tread rubber acts as a series spring in the generation of lateral force response to slip angle. Therefore, tread design has a potential influence on the cornering stiffness.